This is the SolidWorks surface exam, sample exam that you can get on solidworks.com. Let's walk through where you can get this from right here. If you Google SolidWorks certifications, second option right here. Scroll down a little bit and we're looking for CSWPA-SU right here. Don't bother clicking take the exam on as of 2/18/2025. You still can't buy it. Anyway, if you go to exam information and click on this, and right here is the option to download their sample exam. So we're going to be going through that today just as a reference for you guys to be able to use. Here's my completed mousey. I'm going to get rid of that for a second here, and we're just going to go ahead and pull up jump to the test questions section of this PDF that is part of the test package. New computer mouse. Blah, blah, blah. Anyway, so if we've got some reference images here, it's pointing out that we want to start with this shape right here, and side surface should follow fill boundary, and we've got something with 3 degrees right here. So let's talk about this first question here. Design this part. Open the part, imported surface. It contains a surface and a picture. Alright, but before we get started with that, there's 2 things I would recommend doing here. The first thing is go into your options. Under search options, go ahead and type in spline. What we're looking for is down here under system options under sketch. These 2 options need to be enabled. Well, I would recommend these be enabled by default. Enabling the spline tangency and show spline control polygon by default. These 2 will make the life, I think, a lot easier for you guys. So make sure that those are set. Second thing is under sketch, I recommend adding what's called fit spline to your command center. If you right click this, go to customize, type in commands, and type in just spline. It looks like that right there, fit spline. So you want this to be in this area for later. Not a requirement, but there are some things that lend itself to be more accurate if you have that tool available. It's buried under insert and blah 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 here, so I recommend putting the fit spline on the top there. Alright, so let's go ahead and open up this right here, this imported surface in sketch picture. And this is what we start with. Convert to appearances. It doesn't really matter. Real view is fine, or SolidWorks color texture. It doesn't really matter. Okay, if it says that, depending on versions of files and stuff like that. Okay, so let's go back to this. And what's asking us to do is create a 3-degree angled from vertical on the full boundary of the imported surface. Should be flush with XZ plane. So let's see, our XZ plane is going to be this plane right here, our XZ plane, the front plane. Okay, the surface should be flush. Okay, we're finishing. The surface should start with a profile parallel to the YZ plane. So in this case, the YZ plane, that's what I was talking about, is something parallel to this plane right here in this example. That's angled 3 degrees from the vertical along the full boundary. And the shape of the side surface should follow the contour of the footprint in the sketch. After creating, measure surface area of this new surface we're creating. And it's going to give us some answers here that I have saved right there. Alright, so let's go back here. So first thing is kind of considerations as to what it's trying to get to. We look ahead a little bit, we can see where we're trying to get. It's creating this line right here. This is the view from the rear, I believe, but it's 3 pitched out to this side, and if I scroll down a little bit, I can start getting an idea of exactly right there. It's going to be pitched out to the side, so we're going to create a line with a 3-degree angle on our YZ plane. To be able to do that, in this case right here, If we're to create a line right here, it's not going to work too well because we need to create piercings to be able to use surfaces because we're going to be drawing in the lines, as you guys can remember. So the first thing we probably need to do in this case is start using some helper planes. So if I select this plane right here, go to Reference Geometry, hit Plane, then select this edge right there. This will create a helper plane that intersects this surface feature where these 2 points come together. So right at that vertex, this plane will be aligned to that, and we can create a piercing very simply using this new plane as a helper. Next is, I always like using center lines when it's appropriate. We just need the single one right here. And this is just a place to tie everything down just to make sure that things are coincided properly. Next thing is create our line. We're going to use this as the base, but make sure you don't use mids and stuff like that. Go over here somewhere and do not connect it just yet. You want to make sure that this line is disconnected at this specific point, and then we will start dropping in our relations here. So let's go ahead and do our 3 degrees here. Then the next thing is, at this point, it should be movable left and right, up and down here. But we can do this and create a coincident. But I always recommend that you use a pierce when possible. And remember, to do a pierce, you're going to select the end of a point and you pierce into a line. You cannot do point to point. So in other words, I'm control clicking here. You notice that pierce is not available using point to point, either direction. So if I click this and click this, you notice that point is not, that the pierce relationship is not listed here. What needs to happen is point to line. So where this line comes to a stop on this plane, that will allow the pierce to do what it needs to do here. Alright, so as part of that, make sure that you're using pierces when you're doing surfacing for a lot of reasons. Okay. Alright, so there is our first thing, and the second thing we need to do is create a shape of the side surface should follow the contour of the footprint. So this bottom edge right here, there is a footprint, and they provide this really nice high def image. Yes, I'm being sarcastic. Let's go ahead and try that. And this is where selecting that polygon option under the spline control tools is going to pay off. So first thing is, let's create a sketch on this plane right here. Next is, we'll select our spline and we'll drop 2 points, but we do not want to create a relationship except for right here. In fact, we can pull it over here for now if we want, so we can move these spline endpoints correctly when we get close to this. Okay, so at this point we have a single spline, no control handles just yet, but let's take this and we're going to move it to where this vertex is right here, where these two comes together. Okay, so let's create a pierce right there. Okay, you can click and drag and make a coincident, but again, pierce is better if possible. So click here and here. Here's our pierce again. So now it looks like it's fully defined, but what we want to do is open up the handles. And to be able to do that, to see it effectively, because if we go to the top view here, it's a little bit blocked here. Maybe that doesn't affect what you're doing, but I like to take this surface right here and just go ahead and turn it off. So just hide it for the moment. Okay, if we click this, the next thing we need to do is create our handles and just move one of these out a little bit. And then our polygon comes in too. You can just see that gray polygon just hanging out there. Now if we normal this view again, what we can do is zoom out just a little bit. If we grab this single handle where these two come together, it controls both handles at the same time and the angles, which makes life much easier, honestly. Okay, we're going to trace that outside almost bitmappy line and just get it as close as we can. That feels good right there. Let's exit this, and now we can do a contrast to see how accurate we got by hiding this the sketch itself that contains the actual image. You can see that looks pretty good. Drop it on top of there. Okay, so let's go ahead and unhide our surface. And we're going to go ahead and try a couple things here. Okay, so looking at this right here, it's saying open the blah 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 blah, and contain a surface imported. Create a surface on the side using either a swept surface or surface fill. So, just as a precaution with the exam, they're going to give you options similar to this, and you may find yourself farther down in there and still within their tolerances they give you, but there is no rhyme or reason. I would just select whatever the first option is. So in this case, it's telling us to use a swept surface. So swept surface, we're going to use a contour, a line for the path, and then we're going to sweep it using a guide curve. So the second option, doing a surface fill, probably would work, but in this case, we're going to start with the surface, the swept surface, and then we're going to compare and contrast the two here. So let's go ahead and select this as our starting, and that's going to be our our guide, so our curvature display here. So we'll go into surfaces, go into the swept surface, and we're going to be using that profile right here. So we're going to select this as our profile. Then the path, let's try this first. So let's see if this works. So let's use this as our path. It seems to be working. And then let's use this as a guide curve. So immediately notice that it won't allow it. In fact, if we click this, it's going to say there's a rebuild issue. Try to edit these relations, and so what I simply recommend is clear this, and instead of using this top, because of the nature of how it's curving, by the way, this is kind of a hint because it's coming down to basically a zero thickness in the sense of the word. So let's try using this as the start, and then we're going to use the guide curve because of the nature of how that's extending that up. So by using the guide curve, that creates that boundary for us in the top. And now we're in good shape. Okay. So that completes the first part, and let's go ahead and test to see where we're at for it. This, and it's saying after creating the surface, measure the surface area of the surface we just created. The green option right there. So if we click this, click on measure, we're getting 2220.68. If we bring up our key here, 2220.93, and we have a tolerance built in of plus or minus 7. So we are very, very close. We're within 0.3-ish. So no worries in that regard at this point. Carrying on. Let's go to the next question. If you're screaming in the background, they're just little girls doing what little girls do. Okay, question 2. Image for question 2. It's asking us to do is create a fillet of a type curvature continuous connecting the top and side surfaces. That should be really straightforward. A fillet, just the same as you're going to use. It's the same exact thing. And in fact, the tab with the generic setup for the surfaces tab has fillet already there. Then it gives us a multiple choice. So let's go ahead and do that. All right, edge is ready to go. Boop. And here's our fillet option. And I believe, let's see, what does it say to do? Fillet radius 3. Curvature continuous, it was selected here. And you notice that it does not seem to be at least giving you a preview. Let's try partial. So something is not quite right here. In fact, if I click here, it's not allowing me to set this. In fact, let's try this. That's a different one altogether, and that's not going to work, is it? Nope, something is wrong here. What's wrong is there's two surfaces, and it can't fill it unless you have a continuous surface. Continuous being these two surfaces are being treated separately. You can see from the surface bodies folder here, these two need to be knit together. So a couple ways we could do this. Probably the easiest way I like to do is I just hold Control down or Shift, select both of these, then go to knit surface. This would be a good point to do merge entities. You do not create a solid yet at this point, and there's not enough connective information to make that happen anyway. If you did a job and we're actually using that curve, you don't need to use gap control, but in the test you may have to enable gap control depending on the nature of what you're doing. And again, using those pierces as those relationships, will save you a lot of frustration trying to overcome issues and gaps that happen if you're not using the right kind of surface technique, or if you're not using pierces to create relationships. So let's do this, and then you notice something. It creates one surface. In fact, if you click on it, you can see the different surfaces are addressable. But here, now you've got this surface net. So let's go back to fillet. Here we got symmetric 3, curvature continuous, all selected. And that's what we want. Let's try selecting this now. And lo and behold, we have the ability to create that curve. Sorry, that fillet. But you notice something about this. Not a huge difference between these different types. But again, pay attention to what the instructions are telling you, and you should be good to go. In this case, it's saying what is the surface area of just the fillet. Super easy to do. We just select that surface right there. Go to measure, face 1. That's selected here. It shows even a preview. Let's bring this up. Letter B. And in this case, 348.10. And our total is 347.94 here. So we're, 0.15 away. We're good. Okay. All right, step 3. We're going to trim surfaces. Keeping 5 degrees, measure the top surface. So we're going to trim the front edge of this model. Probably one of the easier things to do in this. So all we need to do is draw a single line, drop our dimensions to place, and then we should be good to go. Just draw our line here. I believe that was 115, yep. Okay. I believe that was 5. Yep. Okay, so 5-degree pitch. You can use center lines if you like, not a big deal. And that's all you need. If we go to surfaces now, we can exit if you feel like it, but you notice that trim surface is available. Pay attention to what you're doing in terms of which you're keeping or removing. Since we only have 2 surfaces that are going to be allowed at this point, it doesn't really matter. You can click keep this, you can remove this, etc. So let's try keeping. The trim tool is already selected because I selected the trim tool from the actual sketch that I was using. And then you're just going to use whatever defaults. Typically it's just going to be the natural. Okay, so we're going to do this. Notice the purple is what's maintained, the light blue is what's going to be removed and discarded. Okay, so at this point we have trimmed that mouse face up, and we're asked to measure this surface area right here, which is 3725, 3723, plus or minus 40. They're giving us quite a large gap there, so our tolerance is good, and we can continue on. Okay, last question. Complete the solid. Set our material. Mirror the parts. Apply the material, ABS. And what is the mass? So, probably the hardest part of this entire thing is to create this. So let's step through this a couple things at a time here. I just don't want to see that line as well. Okay. Alright, let's hide this. I just don't feel like, again, I just don't want to see that plane. Alright, so here's what we're going to start with. And again, because of the nature of how we're doing this, we have this whole surface, but we're going to mirror this as a body because it's a surface body. You have solid bodies and you have surface bodies. So we're going to mirror the body, not the feature. So if you go here or something like this, or if you click on this and you're wondering if you go to features, once you exit this, go to features, mirror, and you click here, and you're wondering what on earth is going on. It's because of the fact that you haven't selected the body. Okay, so a lot of times as we'll try and jump around for you. Let's select our mirror first. Okay, and if we go to features and we try to click this, you notice it's not even allowing it. like the fillet's going to be copied over, but I'm thinking that's going to fail. Okay. What we want to do is select bodies right here. Okay. If we do this, you're going to see that things are going to work well. Might want to save a little bit of time. You can hit the knit surfaces option here, and you can propagate if you feel like it. I don't think that really matters, but you can knit or you can knit later. It really doesn't matter at this point. Try both. Okay. The next thing as part of this is establishing the front face of this mouse, which is flat. Okay, so this is where this weird sketch relation, this sketch tool called Fit Spline comes into play if you want to use it. You can feel free to use this edge and just draw a line at the bottom here, such as this. So if I want to go in, click here, sketch on this, connect a simple line like this, and exit our sketch, go to surfaces, let's do a filled for this, and I can just work my way around here. Okay. This would probably work okay. In some cases, SolidWorks likes single entities to work with. So I want to show you that just in case this creates more accuracy or a more accurate result for you. So let's move up one here. So we're going to just go above that sketch I just dropped in. And let's use a 3D sketch. We could create a plane if you want to go to the effort of creating a plane to do this with, but 3D sketch works just fine. So under sketch, you can hit this right here and go 3D sketch. I've got my custom toolbar here, but I can go straight to 3D sketch like this as well. Remember, you typically don't have to start in a plane, but in this case, we don't even need to select anything because we're going to fit a spline onto an edge. So if we click Fit Spline right here, we're going to start over here. Doesn't matter which side, and you can see it's starting to establish a spline. That pink is the spline it's going to create. So it's going to create a single entity. Then last, we don't want to close this. We just want to leave it up in loop. So you can see where the blue and pink dashed line is. It will create a spline right against that line right there. So it creates a single entity for we could use. And now, let's go ahead and finish that out. Drop this sketch back down. And if I click here and here, these two entities right here, this 3D sketch and the sketch that I created from the 2D sketch option, you can probably just create a 3D as well. Go to surfaces and fill it. You'll immediately notice that it connects everything really nice. Okay, so let's go ahead and improve that. At this point, it might be worth looking at the curvature nature of this. Under eval, evaluate, you've got this curvature option right here. This shows colors and will display how curved an area is. So the darker it is, or the closer it is to the black color here, that would indicate almost zero curvature. Green is minimum curvature. So basically it moves from a really, really dark green blue up to green where it's more curved, and then red is very curved, if that makes sense. So basically black, blue, green to red. That's the order of how it tries to display this. So this is really helpful when you're trying to analyze where you've got curvature and where you're missing curvature, if that's helpful for you. You can also use stripes if you feel like it. It'll create something that's a bit more easy to see for some people. Looks like some 80s kind of thing. Anyway. Alright, and then we've got this last option on the bottom here. Just for the sake of demonstration, I'll show you that you can use this curvature again using the Fit Spline. Obviously, splines don't like super sharp edges like this, so we may have to be a bit creative doing this, but I'm going to demonstrate this again for you. So let's create another 3D sketch, and we're going to Fit Spline again. We're going to start here. You can see the nature of this. You've got a little tag here, so let's make sure you click this here, here. Okay, kind of hard to see in there, but we're going to grab that edge right there, and then this. That's going to bring us all the way to the front, and let's go ahead and open up that spline in this case again. Okay. In this case, it's putting the little comb marks out to the side. You guys can see that. Okay, and when I approve this, that spline is dropped into place. And secondly, I can take this, and I can actually do a convert. So you guys can really see that we've got a nice clean edge to use on this. This may be overkill by doing this, but it may come in handy just as a guide, just as a little thing. And then we have one and one only sketch that we can go up into our surfaces, filled surface, and you can see it's already ready to go. You don't have to get in there and click because there's 1, 2, 3, 4, 5, 6, 7 edges that you need to be concerned with. Okay. So you can fix a boundary and try to merge, but you notice that some of these are not available, and that's okay at this point. Filled surface is not the place you want to go to do things unless you've been knitting the entire time. This will become a option to merge result and create solid if you've been creating the nets of the net feature, but we have not been doing that yet. So we'll just approve this. Now you notice that we have 3 surfaces here. The top shell that we started with, the front edge of the mouse here, and then the bottom. This is the point where we're going to merge everything. So again, if I want to do this, I'll select all 3 surfaces, go to knit. Right here, I've got the ability to do a create solid, and I'm going to merge everything at the same time. You can select gap control if you feel like it, but I don't think we need to. Let's see if it's going to handle it anyway. There we go. Okay, last but not least, let's go ahead and create our material. We'll go ahead and select ABS. That looks weird. Whatever. Okay. Let's go ahead and grab our mass properties. And you notice something. This is not solid because it's still surface knit here. So there are maybe cases where, depending on the model you're creating, using a surface knit, you may have to enable gap control. Okay, so let's see if this works. Still nothing. Okay, so there are cases where this last edge right there created some kind of issue that is not allowing this to knit properly. So let's bump this all the way up. So 0.111. So we're going to set this to just 0.1. See if it does it better with this. Okay, we're still having issues with the surface. So what we're going to do is walk this back a little bit, and this is maybe something that you're going to encounter on the actual test. So this is why I'm doing this. So in this case, let's try just doing a filled surface without that spline in this case, because something weird about this corner that is different about how this did it. So let's do a fill. In this case, we're going to walk around. Three, 4, 5, 6. Let's grab that front right there. 7. Okay. Right there. Let's just leave these options open for now and see what happens. Okay, our surface is good. Let's see if this will allow knit a little bit easier now. Create solid, merge entities. Okay, in this case, it created that solid for us. Now you notice this because the mouse properties is now lit up. Surface bodies has gone away, and we have a solid surface body now. Okay, so let's go ahead and grab our mass. 1849.176. All right, do not assume that ABS PC is the same as ABS. Sometimes that ABS PC will just show up in where it's not supposed to be. So let's go actually grab the correct material. And we'll grab this. That's a bit of a difference. Let's see where we're at. 176.87, 176.26. I will take that. As I mentioned, is the first part of this. I was going to show everyone the difference here. I went ahead and used a filled surface for this edge first. And let's walk through the test and see how close it is I set the material to the right one this time. Okay, so same exact technique. Here's our sketches. 5-degree pitch, all the good stuff, piercing the whole 9 yards. So let's look at this real quick. Go back up here. Okay, and the first question was a surface area. So let's measure this. Okay, 225.3, 225.93, close enough. Okay, next thing right here, net these two together. Let's measure this. 354, so that's going to be A, B, C, or D if I'm not mistaken here. 348, so within 10. That's still okay, but it's a little bit farther from the first time. I don't know if you guys remember. Alright, let's go ahead and bring it all the way down to this right here before we mirror. Let's measure this surface right here. Okay, top of surface, what is this? And let's look at if there's any difference between these two. 3721, see, minus 40, so we're well within tolerance there. Let's bring it all the way down. Same kind of process that we did, but again, instead of using a swept surface there, I used a fill surface. So let's do mass properties. 179.70, let's see, 78. 176.87 plus 3.5 grams. So let's math for a second here. 176.87 plus 3.5. 180.37. So you can see in this case, using that different approach to that first surface did create a little bit of a discrepancy. So in other words, using the filled surface for that first edge versus a swept surface gave us a slight deviation from the original. Okay, so just something to bear in mind with the filled. And again, as a comparison here, mass properties, this is at 176 using that technique. And so instead of using a filled surface, I use the swept surface for this per the instructions up here. So in this case where it says use either swept surface or surface fill right there, just bear in mind that you may want to plan accordingly, and if you start to see something deviate from where you're comfortable with, just something to consider. All right, hope that helps.